Hello there and welcome. In this video, we will discuss the two-stage dividend discount model for calculating the intrinsic value of a share. We will start with the basics. First, we'll discuss the basic dividend discount model, its modified form, the constant growth or the Gordon model, and the zero growth model. With the basics done, we will move on to the multi-stage model with an example of a company with two stages of growth. So let's get going. As the name dividend discount model suggests, the dividends received from time to time are discounted based on the required rate of return, and the figures are total to calculate the intrinsic value of the share. Basically, the intrinsic value of the share today is the sum total of the present values of all the dividends expected to be received. Present value is basically the amount that a future dividend is worth today in today's dollar terms. This is summarized as follows. P0 is equal to D1, which is the dividend at the end of year 1, divided by 1 plus R raised to the power 1. That is, the dividend at the end of first year is discounted suitably by using 1 plus R, plus D2 divided by 1 plus R square, which is the dividend at the end of the second year discounted accordingly, plus D3 divided by 1 plus R raised to the power 3, and so on, Dn divided by 1 plus R raised to the power n, and so on till infinity, because a company is a going concern and we expect an infinite stream of dividends theoretically. Here P0 is the intrinsic value of the share today. We are calculating what the share is worth today. The numerators on the right hand side of the equation are D1, D2, D3, and so on. These are the dividends at the end of year 1, 2, 3, and so on. And R is the required rate of return for the investor, or the discount rate. Note that the numerator in the first term of the equation is D1, not D0. That is D1, which is the dividend received at the end of the first year. Here P0 is the intrinsic value of the share today. Now D0 would be the dividend already received or the dividend received today. So to estimate the intrinsic value of the share today, that is, to estimate P0, one needs to start with the dividend at the end of year 1, not the dividend already received. This has to be kept in mind, as we will use this concept in variations of the dividend discount model, especially the two-stage model. Now, a company is a going concern. That is, it does not have a fixed term or a date on which it extinguishes its entity. It lives forever, unless, of course, it's liquidated. So the going concern has an infinite life and hence an infinite number of possible dividend payments. This makes it very difficult, practically impossible, to use the dividend discount model in the above form. This is especially true because the investor does not want to hold the shares forever. He may have a holding period in mind, which normally shareholders do. He cannot forecast an infinite stream of dividends and an appropriate discount rate because the rates also keep changing over time. To overcome this, the following modified or simplified dividend discount model is used. The equation is as follows. P0 is equal to D1 divided by 1 plus R raised to the power 1 plus D2 divided by 1 plus R raised to the power 2, and so on till Dn, which is Dn divided by 1 plus R to the power n is the term, nth term. And then you have Pn divided by 1 plus R raised to the power n. This equation, the terms are as follows. P0 is the intrinsic value of the theoretical value of the shares today. Dt is the dividend expected to be received at the end of the period T. That is D1 T is equal to 1, D2 T is equal to 2, and so on, and Dn T is equal to n. Again, to get P0, you need to start with D1, not D0. Therefore, T is equal to 1 to n, not 0 to n. R is the required rate of return or the discount rate on the share, and n is the holding period. Pn is the expected selling price of the share at the end of the period n. This is important. So if you look at the timeline figure below, for a, say, 6-year holding period, you have D1, D2, D3, D4, D5, and D6. These are 6 dividends to be received at the end of year 1, 2, 3, 4, 5, and at the end of year 6. And P6 is the expected selling price. Now you discount all these dividends suitably. D1 will be discounted by 1 plus R, D2 by 1 plus R square, D3 by 1 plus R raised to the power 3, and so on. And D6 will be discounted based on 1 plus R raised to the power 6. Likewise, P6, which is received at the end of year 6, the expected selling price is for the point at the end of year 6. You will discount this P6 by 1 plus R raised to the power 6. Then you total all those present values, that is all those discounted terms, and you get the intrinsic value of the share at 0.0, which is today. As you may note, this modified dividend discount model fixes a holding period n and requires an estimation of the selling price Pn at the end of the holding period. Let us understand the dividend discount model with an example. Say there's a company called ABC Corporation. The expected dividends of ABC Corporation at the end of years 1, 2, and 3 are $7, $8, and $9 respectively. The expected selling price of ABC shares at the end of years 3, the 3 years is $29, and the discount rate is 10%. Based on the modified dividend discount model, the intrinsic value of ABC's shares today is $7 divided by 1 plus 10%, plus $8 divided by 1 plus 10% raised to the power 2, plus $9 divided by 1 plus 10% raised to the power 3, plus $29 divided by 1 plus 10% raised to the power 3. So all these inflows are discounted suitably using the discount rate of 10%. The figures are 6.36, 6.61, 6.76, and 21.79. These present values are totaled, and we get $41.52 as the intrinsic value of ABC Corporation's shares today. Now let's look at another form of dividend discount model, the constant growth model, which will be used in the multi-stage model. This model presumes that the dividends will grow at a constant rate. For example, if the dividends are expected to grow at 5% each year forever, and the current dividend is 1, the expected dividend at the end of the first year and second year will be 1.05 and $1.1025, and so on. The infinite stream of expected dividends is discounted using the required rate of return, just like in the basic dividend discount model. The formula for the constant growth rate model is as follows. P0, which is intrinsic value or the theoretical value of the share today, is D0 into 1 plus G divided by 1 plus R, plus D0 into 1 plus G whole square divided by 1 plus R square, plus D0 into 1 plus G raised to the power 3 divided by 1 plus R raised to the power 3, and so on. And last term will be D0 into 1 plus G raised to the power infinity divided by 1 plus R raised to the power infinity. D0 is the current dividend payment. When you multiply that with 1 plus G, you get D1, which is always the first term in such calculations. And D0 into 1 plus G whole square, since the growth rate is constant, is going to be the dividend at the end of the second year. G is the constant growth rate of dividends. R is the required rate of return or the discount rate on the shares. Again, note that the numerator in the first term of the RHS is not D0, it is D0 into 1 plus G, which is equal to D1. That is the dividend at the end of year 1. Again, it is practically not possible to solve this equation because you have infinite terms. So there's a simplified version of the above equation, which is P0 is equal to D1 divided by R minus G. This is a mathematical simplification where D1 is the expected dividend at the end of year 1. Again, it is not D0, remember that. And G is the constant growth rate of dividends, which we have had in this equation. And R is the required rate of return or the discount rate on shares. So the formula is P0 is equal to D1 divided by R minus G. Since the numerator is D1, not D0, you are given D0. Suppose in the question, you must calculate D1 is equal to D0 into 1 plus G. This is called the Gordon growth model. The Gordon model is suitable for valuation of very large and broadly diversified companies. Gordon model makes the following assumptions. Firstly, that the dividends grow at a constant rate. The constant growth is going to continue indefinitely. These are theoretical assumptions, but we have to make these assumptions, accept these assumptions if you are to calculate the theoretical value of the share. The required rate of return R is greater than the constant growth rate, because if R is less than G, the model does not work because the intrinsic value becomes negative and thus meaningless. And if R is equal to G, the denominator becomes 0 and the intrinsic value calculation becomes mathematically meaningless. The constant growth model is called Gordon model because it is named after Myron J. Gordon, who played a large part in its development and use. Let us understand this with an example. If ABC Corporation has a current dividend of $200, which is already paid today, say, and an expected constant growth rate of 10%, and the required rate of return is 14%. Required rate is greater than the constant growth rate here. The intrinsic value of ABC shares today can be calculated using the Gordon growth model. The first step is to calculate D1. We have been given D0, which is the dividend today, that is $200. The dividend at the end of the first year is going to be D0 into 1 plus G, which is $200 into 1 plus 10%, that is $220. Now, according to the Gordon model, we can calculate P0 is equal to $220 divided by 14% minus 10%, that is $220 divided by 4%, and the intrinsic value of the share today comes to $5,500. Now we have used the expected dividend after 1 year to calculate the intrinsic value today. Always remember this. Now let's go to the zero growth model. Let us presume that the dividends do not grow at all. They remain constant. For example, let's say ABC Corporation pays 5% dividend on its preference shares of par value $50 every year. The owner of the preference share receives a fixed dividend for an infinite period. Since the dividends of a preference shares are a perpetuity, the intrinsic formula for such a scenario is derived from the constant growth formula. That is P0 is equal to D0 into 1 plus G divided by R minus G. If you substitute 0 instead of G, you will get D0 divided by R. Therefore, for a zero growth model, P0 is equal to the constant dividend, even today or tomorrow or after 1 year, it all remains the same. After 10 years also it is the same. So you're using the constant dividend and dividing that by the discount rate. Therefore, if the discount rate is 14%, the intrinsic value of ABC shares is 5% into $50, which is basically the dividend, divided by 14%, and the value comes to $17.86, the intrinsic value of the shares today. Now that we have covered the basics, let's discuss multi-stage growth model. The multi-stage growth is a scenario where the expected future dividend growth must be described using 2 or more growth rates. Let's discuss a 2-stage dividend discount model to illustrate this. A 2-stage growth model assumes near-term growth at a given rate for some period, say 2 years to 10 years, followed by a different long-term growth rate that is sustainable, which is constant. In the 2-stage model, a dividend growth is forecast for the near term, and it is assumed that the growth rate in the long term will be a bit more than the required rate of return because of the limitations of the Gordon growth model. That is, R has to be greater than G. The equation for the 2-period growth model is as follows. P0, which is the intrinsic value of the share today, is the summation of D0 into 1 plus G1 raised to the power T divided by 1 plus R raised to the power T. This is the term 1, plus Dn into 1 plus GC raised to the power 1 divided by r minus GC, and this whole thing is discounted by 1 plus r raised to the power n, and this is term 2. So summation of term 1 and term 2 will give you the intrinsic value of the share today. It looks complicated, but we'll discuss it to make it a little simple. Here P0 is the intrinsic value of the share today, D0 is the current dividend. G1 is the growth rate of dividends in the initial phase, the supernormal or subnormal phase. GC is the constant growth rate when dividends are constant, growing at a constant rate. R is the required rate of return, N is the number of periods of supernormal or subnormal growth. Dn is the dividend at the end of the abnormal growth period. T ranges from 1 to n. Again, G1 is the growth rate of dividends in the initial phase, where the dividends are growing at a supernormal or subnormal rate, and GC is the constant growth rate of the dividends when the dividends are growing at a fixed rate. Note from the following equation that the term in the first box, that is term 1, applies to a dividend stream for the first n periods when the dividends grow at a super high or super low rate of G1. Here T ranges from 1 to n. That is, there are n dividends to be discounted. The dividends of this stage are discounted at the required rate of return, R. Note that there is no requirement for the growth in the first phase to remain absolutely constant. It could go up or down. So instead of G1, we could have GA, GB, GC, but generally we take a single growth rate for calculations in questions. Dividends could vary, the growth could vary, and one could calculate based on the estimated growth rates at various points in time. Each of those dividends need to be appropriately discounted to get the present value. The sum of the present values of those dividends in the first phase gives the intrinsic value of the share today based on the PVs of the dividends up to the end of the nth year. But this is just one part of the intrinsic value. The term in the second box, term 2, is the constant growth version. Here the dividends at the end of period n plus 1 are first divided by r minus g, and the resulting figure is discounted by the required rate of return. Basically, dn into 1 plus gc gives you dn plus 1. And this divided by r minus gc gives the intrinsic value of the stock using the Gordon growth model, albeit based on dividend n plus 1. Therefore, this intrinsic value will be the intrinsic value at time n. Remember, when we used to take D1 to calculate the intrinsic value of the share using the Gordon growth model, we used to get P0, which is the intrinsic value today. So when we use dividend n plus 1, we get the intrinsic value at time n. That is n plus 1 minus 1. Note that if we use the n plus 1th dividend in the Gordon growth model, we will get the intrinsic value of the share at the year n, which is equal to n plus 1 minus 1. Therefore, this figure needs to be discounted by 1 plus r raised to the power n, not 1 plus r raised to the power n plus 1, because the present value pertains to the time point n. Note that the growth rate in the second phase must be constant, as we are using the Gordon growth formula to calculate the intrinsic value at that point n. The sum of terms 1 and 2 gives the sum of the present value of streams of dividends at both stages, which is the intrinsic value of the stock today. Let's take an example to understand this. ABC Corporation intrinsic value today can be calculated using the formula we discussed. It is a two-stage dividend discount model. P0 is the intrinsic value of the share today, which is to be calculated. And D0 is the current dividend, which is $10. Growth rate in the initial phase, G1, is 10%. Growth rate in the constant growth phase, is 5%. That is GC. R is the required rate of return, which is 12%. N is the number of periods of supernormal or subnormal growth, which is 3. Let's say for the first 3 years, the dividends grow at 10%, and thereafter they go at a constant rate of 5%. And Dn is the dividend at the end of the abnormal growth period, which is to be calculated. We need to calculate that dividend. So based on the above equation, term 1 is the present value of the dividend at the end of year 1 plus present value of the dividend at the end of year 2 plus present value of the dividend at the end of year 3. Now, dividend at the end of year 1 is $10 into 1 plus 10%, which is $11. And present value of this dividend is equal to $11 divided by 1 plus 12%, which is $9.821. Similarly, dividend at the end of year 2 will be $10 into 1 plus 10 raised to the power 2, which is equal to $12.10. And present value of this dividend is $12.10 divided by 1 plus 12 whole square, which is $9.646. Finally, dividend at the end of year 3 is $10 into 1 plus 10% raised to the power 3, which is $13.31. And present value of this dividend is $13.31 divided by 1 plus 12% raised to the power 3, which is $9.474. So the total value of term 1 is 9.821 plus 9.646 plus 9.474, which is $28.94 approximately. Now, $28.94 is the sum of the present values of the expected dividends up to the period n is equal to 3 years. Hence, this is the intrinsic value of the share based on the dividends till the end of year 3. Coming to term 2 of the equation, term 2 is based on the intrinsic value of ABC shares calculated based on the Gordon growth model at the end of year n, which is end of year 3. For this, we need to use the dividend at the end of year n plus 1, not today and not at the end of year n. This is because the constant growth rate starts at n years, not today. Therefore, this intrinsic value is equal to dn into 1 plus gc, that is d3 into 1 plus the constant growth of 5%. And we have to divide this by R minus GC, which is the denominator in the constant growth formula. This gives us the intrinsic value of the share at point N by using the Gordon growth formula. And if we discount that by 1 plus R to the power N, we get the present value of the intrinsic value today. The numerator of the term 2 is D4 and the denominator is R minus GC, which is D3 into 1 plus GC divided by R minus GC. We know that D3 is $13.31, which we had calculated earlier. We multiply that with 1 plus 5% and divide by 12% minus 5%. And we come to a figure of $199.71. This figure 199.71 is the intrinsic value of the share at n years based on the constant growth model. This has to be discounted by 1 plus R to the power N to get the value of term 2 as follows. $199.71 divided by 1 plus 12% raised to the power 3. This comes to $142.15. Therefore, the intrinsic value of ABC is equal to term 1 plus term 2. Term 2 is $28.94 plus $142.15, which comes to $171.09. To understand this better, let's look at this timeline. We have year 0, 1, 2, 3, 4, 5, 6, and so on till infinity. And we have D1, D2, D3, and then D4, D5, D6, and so on. From D1, D2, and D3, if we take the present values of these dividends and we sum them up, we get the intrinsic value of the share at point 0. That is intrinsic value of the share today using the simplified dividend discount model. That is because till point N, till the end of year 3, we can use that formula. After that point, there is constant growth. And to calculate the intrinsic value using the Gordon growth model, we need to use D4 in the numerator. And we divide that by R minus GC. And based on that, we get the intrinsic value of the share at the end of year 3. Again, we discount that intrinsic value, which we have calculated based on the Gordon model, by 1 plus R raised to the power 3 in order to get the present value of that value at the starting point, which is 0. The calculation is as follows. $10 into 1 plus 10% divided by 1 plus 12% raised to the power 1. This is the present value of the first dividend, D1, plus $10 into 1 plus 10% raised to the power 2 divided by 1 plus 12% whole square. This is the present value of D2. And you have the third term, $10 into 1 plus 10% raised to the power 3 divided by 1 plus 12% raised to the power 3. This is D3's present value. When you total these three present values, you get the intrinsic value of the share using the simplified dividend discount model, and you get the intrinsic value at point 0. For the constant growth phase, the term 2, the calculation is as follows, $13.31, which is D3 basically, into 1 plus 5%. We cannot use 1 plus 10% here because henceforth, from point 3 onwards, end of year 3 onwards, we'll have a constant growth rate of 5%. So this $13.31 into 1 plus 5% is D4. And when we use D4 in the constant growth model, we get the intrinsic value at point 3, end of year 3. So the numerator, we have D4 and we divide that by R minus GC, which is 12% minus 5%. And we discount that by 1 plus 12% raised to the power 3. This is because the intrinsic value calculated pertains to the intrinsic value at the end of year 3 at that point. Here we come to the end of this video. Thanks for watching and happy learning.